G'day guys, welcome back. I did say that I'd do a video later on this. I've obviously only just received it and set it up or set the software up for it today. I haven't had a chance to go through instructions and check if it's got the latest firmware on it, because you can update the firmware on this. But I've just grabbed the BC550, potential BC550. It's a dodgy one from some online reseller. I'm not sure. It's not one of my board pulled ones or ones that's come from DGK or JCar or something like that. So anyway, with just the unit itself, I think you can just scroll through and see a few different things on the screen that it's got. Alright. But via software, it'll actually do all of this. Let me just set myself up a bit better. Okay. So, actually, you know what? I'm just going to pause this and put the phone in a holder. Just give me a sec. Okay, that holder idea didn't really work, but holding the holder seems to be getting me at a better level for you guys, so I'll just do it like this. But as we can see, we get our voltage between the base and the emitter at base current of 1 milliamp. We get our voltage between the base and emitter at a base current of 5 milliamps. Voltage between collector and emitter, saturation 0.029 volts at collector current of 5 milliamps and the base current of 1 milliamp. Collector current leakage current on the collector 0.000 milliamps. It'll tell you obviously the pin out and what sort of transistor it is or device that you've put in there. Now we can do plots. There are parameters that we can change, and then we can curve trace the transistor. So this graph here, this is collector current versus the voltage between the collector and emitter, and it's plotted out at different base currents. And you can see over here the collector current in milliamps on this scale, and over here the collector emitter voltage. Okay, the next one, we've got the HFE, which is the DC current gain, versus voltage between the collector and emitter. And again, it's graphed out. We've got the current gain here, collector emitter voltage here, and the base currents for each of the lines or plots. We've got also gain versus collector current. I think you guys can see what's going on here. Same for collector current versus voltage between base and emitter. So your VBE drop, how it affects the collector current. And then finally we've got collector current versus base current. And yeah, you can zoom in and stretch these things apart. I haven't played around with the software too much, but as you can see, you can definitely zoom in and zoom out and move stuff around. And I don't know what I've just done there. Oh, there you go. I'll be back in a sec. Okay, sorry about that guys, one of my mates just came over. I'm going to have to wrap this up soon because I also have to go do my shopping and do a few other household chores. I can't spend the entire day in here as much as I'd love to. But what were we up to? Oh yes, collector current versus base current. So there you go. And you'll notice also on each plot it will give you a little test circuit. So I guess that's your maximum conditions here. 0 to 12 volts you can put across the collector and emitter with a load of 700 ohms, I guess, or more. Current source 0 to 10,000 microamps. So 1,000 microamps, that'd be a milliamp. So to 10 milliamps you can test up to on the base current. So there you go. Yes, this thing can test other things too, like diodes, Darlington transistors, triacs, thyristors, heaps of different devices. We will do videos on this in the future. Like I said, I just got this thing today and I just wanted to show it off. Not for myself, for its purpose. Like I genuinely think this is a really cool piece of kit. Obviously I still need to finish my full high power curve tracer kit so that I can actually curve trace, power devices and actually do stuff like this, look at gain versus collector voltage, with voltages above 12 volts and base currents above 10 milliamps, for example. I need a device that can stick maybe 1 to 10 amps or 1 to 5 amps in the base and hundreds of volts on the collector, something like that, like a good old Tech 576 curve tracer, but a modern day version. It's basically what I want to build. But between that and this here, I'll basically be able to make my own data sheet for any component that's got 3 pins or less. So yes. Oh, well, and obviously the LCR meter too for all the other components that aren't active. I mean semiconductor components, sorry. But yeah, passive components, what I meant to say. Well, I said not active, so I wasn't wrong, but yeah, you guys get the drift. Alright, so that's it for tonight. I just want to run over that. Very, very, very happy with this little guy. Couldn't be more impressed. You can unplug it to turn it off, eh? It's funny like that. You turn it on. When it's unplugged, it turns on. You turn it off. It turns off, but when it's plugged in, it just automatically comes on and off. Anyway, that's that. The other thing I'll give you guys a quick look at, because last time I did this, it came out just absolutely crap, is just some of the software that's on my computer. There's really random things, like binwalk and Python and stuff like that over in this corner. I've used it once. I was extracting EEPROM data out of a microcontroller from a Panasonic stereo system I was fixing. The Neo programmer thing, that's just for this little programming tool. The CH431A that does UART, I think it does SPI, serial, 8 different EEPROMs and stuff like that. Can flash a lot of different devices. Just a basic programmer. Then I got some other random crap there, just some CAD software for different bits of equipment I've got. Ian Scott Johnson's WinGPIB. What else we got? VAFFT, LabVIEW, good calculator, scientific calculator, some different stuff, PI Spice, LT Spice, the DCA Pro software, waveform editor for my ARB, I think. Yeah, just some random stuff on there. The other thing that I have too, because I've shown you guys my component collection, but I also have an amazing data sheet collection. It literally just, I've probably got as much data sheets as components. Probably not. I've probably got more components than data sheets, to be honest with you. But I try and save stuff as I go. There's a lot of stuff in here I've actually got to organise and correctly name. See, this was when I was fixing this Panasonic stereo. I just saw myself scroll past it. There's an MN101 something. Yeah, I thought I just saw it. Oh yeah, here it is. 101 A16 series micro. This is when I was hacking into a micro in a Panasonic, or I think it was a Sony stereo system, I can't remember, but yeah, there's some random stuff in that, the data sheet collection. Yeah, software, data sheet collection, DCA Pro video that I promised. That's it. I'll do some more work on this panel meter tomorrow, guys, and report back. Have a good night, people, or a good day wherever you are in the world. But I'll see you soon.